In this module, we're going to learn how to create functions. And in C++ or any language, functions are very versatile and very practical because you can create a set of tasks within a function, and then you can borrow or copy that function for other programs. So we're going to learn how to create functions and the different types of functions that you can create with C++. We are going to go over the conditions for project one, which is very important that you work on project one and get as many points as you can, since it's 25% of the grade for the whole class. We're also going to talk about mathematical libraries, which we talked about a few, but we're going to see a little bit more today. And then I'm going to have more feedback on work on project one, hopefully based on questions that I get from you. Let's talk about project one. For project one, we're going to read a file, or you should create a script that can read a file. I will type the name of the file with a certain structure that is going to be given, and the code should be able to read the file. So we're going to read a matrix, and I'm going to go over what's a matrix in a few minutes. I think a few of you already know what a matrix is, but when you go to your modules, you're going to go on module 4, and in module 4 you're going to find these two files, mat4.txt and mat44.txt.txt. You can actually download it and change it to change the file. This is typo, but you can read that, or you can just read these. As long as the code can read either or, you're fine. So the file, it will basically have this structure. It will tell you the dimensions. It will tell you the dimension of the matrix. So this is a 4x4. I guess by now let's talk about what is a matrix. So remember that a matrix is an array or a vector of vectors where data is organized in rows and columns. So for instance, let's say A is a number, or could be a string, could be whatever. So this is position 1, 1, meaning that is row 1. Rows are these ones. So row, row, and columns are these ones. The vertical ones are columns. So column and column. So this is row 1, row 2. This is column 1 and column 2. Therefore, this position is row 1, column 1. This position is row 2, column 1. This position is row 1, column 2. And this position is row 2, column 2. So this matrix could be, this is a 2 by 2. Matrix could be a 3 by 2 matrix, for instance, would be 3 rows here, Y and Z, and 2 columns, A, B, C. This is a 3 by 2 matrix, and a 2 by 3 is X, Y, A, B, P, Q. So 2 rows, 3 columns. So this particular file will have a square matrix, meaning that is the same number of rows and the same number of columns. And the file is 4 by 4. So it's 4 by 4. And the second file is 44 by 44. And the file is given in this structure. First, the dimension is going to give you the number of rows and columns. Symmetry. So when we talk about a matrix, we have, let's say, this matrix right here. So when we talk about a matrix, let's say this matrix right here, which is 4 by 4. So let's say we have 2. Let's create the diagonals first. 2, 1, 3, 4. This is my diagonal. And then we're saying that if it's symmetric, means that whatever is here at the top diagonal is the same as whatever is here at the bottom diagonal. So for instance, if we have a 5 here, then we have a 5 here. Let's say we have a 7 here, then we have a 7 here. And if we have 8 here, we have an 8 here, right? Now we have a 4, then we have a 4, and then we have a 2 and a 3, and then we have a 2 and a 3. So this matrix is symmetric. Therefore, many times to save space in memory, computer code or engineers save this matrix as a symmetric matrix, and they say it's 5, 7, 8. It's going to be 1, 4, 2. Then this says 3, 3, and 4. And they say everything else is zeros. And they say, but this is a symmetric matrix. So when they send this matrix to somebody, they say, oh, okay, we have to put the symmetry in the matrix when we use this matrix. So that's why when I give you the file, it says symmetry is 1. In this case, 1 means true. So that means so in this case, the symmetry 1 means is symmetric. 0 would be no, 1 means yes. And band is 4, so it basically means that the bands are, and bands, the band part means that this is the band, is the diagonals. So for instance, we said that we have 1 band, 2 band, 3 bands, and 4. Since it's symmetric, then we can expect that the same numbers will be on the bottom diagonal, therefore there's going to be 4 bands underneath, but the total number of unique bands, independent bands, is 4. Therefore, here we have band equals 4. And this is very useful because there's something called sparse matrix, where sometimes you have a matrix that is 1,000 by 1,000 or more, 1,000,000 by 1,000,000. So let's say just 1,000 by 1,000. And then you have your matrix, but only a few rows contain data. The rest are 0. So this is useful because when you read the file, it tells you, oh, there's out of 1,000 by 1,000, there's actually 6 bands. Everything else is 0. Therefore, you can go and optimize your code to read the values. So in this case, the band is 4, means that it's completely populated, is symmetric, and the dimension is 4. So how you read this matrix is the following. So let's go back to our notebook. So it says that we have in the diagonal, we have, so how this works is that it will tell you, okay, the dimension is 4, the symmetry is 1, it means it's symmetric. If you notice, it's symmetric because here you have this point. If from matrix4.txt, you have at this point you have a 0, and right here at the opposite end you have a 0. For instance, you have a -1, you have a -1, -1, symmetric -1. This is 0, symmetric is 0. This position 2, comma 4 is 2.2, and then the position 4, comma 2 is also 2.2. So symmetric means that the row and the column interchange. For example, this is the other case. In position row 3, column 4 is 2.2, and then in column 4, sorry, in row 4, column 3 is also 2.2. So this is symmetric, and the way you read the values is, okay, so for the first row, is reading by rows. The first row has 3 values, so 3 independent values. That means that if it's a 4 by 4, one of them is going to be 0. So in position position 1 is going to be a 4, which is right here. In column 2 is going to be a -1, so it's right here. In column 3 is going to be a -1. And there's no column 4. So we know that we have 3 values. This is 1, 2, 3. And there's no column 4. We already have the 3 values, so column 4 has a 0. Then we move to the second row. Second row has only 2 independent values, and they're located at column 2, -1. So 1, 2, -1. And at 4, 2.2. So 3 will put a 0, and we'll put a 2.2 in column 4. Then we move to row 3, and there's only 2 independent values at position 3. So we have position 3 is -1, and position 4 is 2.2. And finally, for the fourth row, we have only 1 value, and that is at 4, column 4, and we have a -1. So at this point, you have the upper diagonal completed. Since it's symmetric, you have to do another step where the positions interchange, where before was a row position, now it's a column position. In other words, this is row 1, column 2. Now, whatever is in column 1, row 2 will have the same value. So -1. This this third column will go to the third row, so -1 will go here too. And then this 0 is going to be the same as this 0 here. So and so on and so forth, you continue to fill up the positions until you get your matrix red. This file is very common format for printing a matrix. So project 1 is going to be reading this file and outputting the matrix. Let's talk about functions, or sometimes called procedures. We're going to talk about what functions are and how we generate or design the functions to be incorporated in a code. So first of all, what are functions? Functions are parts of a code that perform a task or multiple tasks. Functions can be used as many times as you need them. The way you use them is by calling them with the function name. They're immutable variables, meaning that the variables without the function will remain the same unless you input different data value from the function itself. They can do recursion over loops. So many times in functions, you generate loops to generate the data or read the data that you need. And most of all, functions are pure and simple. You create a function and you call it, the function executes a part of your code. Functions are easy to understand, that's for sure. You just put an argument and you use that argument within your function. They're easy to debug and test. So a lot of times functions are recommended because you can segment your code and see where the bug or the error is. And by creating functions, you can later on do multi-threading or parallel computing in an efficient way because the functions can be sent to different processors. So for example, let's go over a function. So before we go to dev++, I'm going to point out that the main function still exists, and it's right here. And All this is the main function. And the new function now, which is the one that we're going to develop, is a function called func, short for function, and is just creating a function just like the main function. The key point to remember is that you call this function from your main function. So notice that right here, we simply call the function. There are no arguments, nothing is passed into the function. Therefore, no arguments need to be incorporated into the parentheses. This is the simplest function that you can create. And then void means that it's not going to return anything. Unlike main, which is int, returns a 0, which is an int, void is not going to return anything. If you print to screen, that I guess you're simply outputting a value, but it's not necessarily returning anything to the code. So let's go ahead and create this function. The first line is going to be the include C standard library. Include C standard input output library. And then we're going to create our main function. We're going to return 0. And at this point, we have the key components for code to be able to be compiled and execute. We have our header library where we're going to use our puts, which we're going to write in a second. So remember, depending on what you're going to use in your main function, you're going to have to use the header library appropriate for the case. In our case, we're going to call a function called func, which we're defining in a minute. And we're also going to say write or put this is the main function. Main. So we're writing this line right here. Now we have to define the function func, and for that we're going to say that the function is going to be void, meaning that it's not going to return anything after we call it. And we have to use the open and close curly brackets because we're going to create a statements inside the function. So notice that there's no input argument. And here we're going to put another comment, or another, we're going to output to console another line, and we're going to say this is the function called func. When we run this, let's see if we have any compilation errors. And we have one error because we missed the semicolon. Let's compile again. And we missed the semicolon here. Let's compile again. And we misspelled the name of the function. Let's compile again. No errors. When we run it, we get this is the main function. So notice that first is going to run the main function and it's going to output this. And then it's going to go into the function and then it's going to output the function here. So it would be different if I print this after I call the function. In this case, it would be the other way around. Let's compile it again and rerun it. And in this case, we have first is going into the function and is outputting this call, or is outputting this string, and after that is executing this other output. main function main. Let's look at another two examples. This one first, and then this one. In this one, we have the in main function, where we're going to use the function, but this time the function is going to have an argument. And we can use the same example for that, because the only difference is that we're going to have an argument. So let's go back here and let's copy this. Let's create a new function. And now we're going to say that my function is going to have an argument. It's going to be an int I. And at this point, we're going to print the int. So we're going to change this. And we're going to print %i / comma I. And the same thing here. What we need to do is input the argument, and we simply input any number. We said it was going to be 35. So let's see if we have any compilation errors. We're going to call this function example2. And we have an error. Yes, and the error is because we're going to be printing the variable. In this case, we're going to have to use fprintf, not fprint. Fprintf is for files. Right now, we're going to use printf. We have no compilation errors, and when we run it, we have that we call the function, and then we go to the function, and we say this is the function called func, F-U-N-C, and the input is 35. And then it's going to execute the rest of the main function, and this is the function main. So this is how you define functions. These two are functions. The difference is that this is the main function that is always going to execute first, and then you can call different functions. For instance, you can have, from the example before, now you can do, this is going to be function 2, and say you're going to call function 1. Function 1. Function 1 and function 2. And now here we have to call function 1, which has no arguments. So function 1 has empty arguments, and if we try to compile this, we have no errors, and if we run it, you're going to have function 1, function 2, main. So you can create as many functions as you need, and you can call them from the main function if you want to use them. The second example, or the third example, is how to input or how to pass arguments with characters or strings. And in this case, we can use a similar code as we did here. Let's copy the whole thing and create a new one. And in this case, we are going to get rid of function 1 here and here. And we're just going to simply call this function. All right, and the arguments are going to be a constant character, a pointer type character. So let's input a pointer type character, capital S, or lowercase s. And then we're going to say this is the function, and we're going to print I, comma, string. And we need to output comma I, comma, s, because we have two variables now. And the input for the function is going to be here. We're going to input a string called myString, or this is a string, and then let's try and run it to see if we get any errors. So we did get an error because there's no such thing as function2. Now it's only called function. No errors, and execute, and there you go, 35 on myString. So let's go over it again. The function is type void, then is not gonna return anything, and it has two arguments. The arguments are separated by a comma. Argument number one is a number type int, so a variable type int, and the argument number two is a string type character, and it's a constant. So you can remove this if you want. It was to just show you the example. And the second argument is the string type character, and when you call the function, you simply type your int and your string, and all of my function, all I'm doing with my function is simply printing the values. So let's go ahead and run it one more time, compile it, run it, and then you can see how you pass the arguments through the function. So in this particular example, example 4, we're going to have a function that is going to be outputting result, or is going to return a result. Let's look at example 4. In this example, we're going to learn how to create a function where we need to return a value. Before we were using void, meaning that we didn't have to return anything. The function didn't expect anything in return. But now we're going to use a function that returns something. So in that case, we declare the function with a type that we're expecting the return to be. In this case, it's going to be int. So let's go ahead and run this example. If we go to dev++ and we create a new one, a new source code, we're going to say, okay, we are going to use include and C standard input output, and that is because I'm going to use printf. This will let me use printf. And I'm going to create my main function, int main curly brackets return 0, and now I can write all my content here. So first of all, I'm going to say puts to write out this is the main function main, and then I'm going to say int y equals function, and I'm going to input 35 and my string. Okay, so that is my function. And then I'm going to print f y equals %d, because I'm using an int, \n jump line, comma y. Y is my function. Okay, and this is what I need to do in my main, except for here I need to put semicolon. And now let's define the function. So now it's going to be a type int function, and it's going to have int I, a number, comma, const char pointer to string. So it's going to be 2 arguments, an int in a string, and then my brackets. Since it's going to be int, the type int, I need to return something. And now I'm going to return, say we need to return the result is 2 times my variable that I input. So if I input 35, I should get 70. Okay, so here I'm going to say print f semicolon, and this is the function called func with arguments I, comma, s, and for that I need to input I and s. Okay, so what I return is 2 comma y, and I'm gonna print here what I return. So let's see what this does. Example 4. No compilation errors. I can execute it, and then I get my main function that it says this is the main function, and then I get my function with the input is int and a string. The string is type character, and I'm printing it right here with printf, and then my function is going to return 2 times I, which I print right here y equals my return from the function. So this printf in line 12, what it does is that it's going to show what I return from my function. And the return, as I said, is 2 times I. So this is example number 4, which shows you how to call a function. Example 5 will show you how to input an array as the argument for your function. So in this particular case, what we want to do is create an array. In this case, is an array of 5 positions. And we're going to create a function where I input my array and type int, which is going to be my size of the array. And the function will basically call the array as the argument and read it. If it works, then this line should print the position of the array. So let's go ahead and do this example. New code. We're going to use the include standard input output.h, and we're going to include math.h so that we can use the arrays for our code. And then we're going to create a function called int main, which is the function that we need every time. And we're going to say return 0. So here, what we want to do is create an array, which is going to be a type int array, and it's going to have 5 positions. And we can declare right now, we're going to say 0, 1, 2, 3, and 4, and an int n equals 5, which is the size of the array. Semicolon and semicolon. Then I'm going to call my function func, and the arguments are my array, comma, n. So I have two arguments. One is the array, and the second one is the int. So now I can declare my function, which I'm going to declare up here. It's going to be a void. It's going to be type void, so I don't need any outputs from my function. I just need to use my function and call it. And I defined it with a void as function with the arguments type int array. And here we need the brackets because it's an array. And we're going to call my second argument size, which is n, in my main function. In this second function, we're going to call size my n equals 5. Then what I need to do is printf array position 0 equal to an int, so %d, and this is going to be comma my array at position 0 and semicolon. So if I compile this, I should first save it as example 5, and I get an error because I didn't write my semicolon. Another compile, no errors, and run it. When I run it, I see that my printf shows array equals %d, which is the first position of my array. So I can do a for loop, or I can do a while loop, and I can read all the positions in my array. I can do for I from 0 to size, which that's why we have size here. And I can print all the positions of my array. So this is how you call a function with arguments that have with an array as the argument. First, you define your array in the main function, and you call the function in the main function simply with the array or the name of the array. Here you don't have to declare with brackets. Is when you declare your function that you declare the inputs or the arguments as type array and type whatever type you want your second argument to be, or your third argument. If it's a string or a double, when you declare your arguments, this is the way you do it. So notice that an example here, what I did was that I actually defined my function after my main function. And if I do that, when I try to compile it, I'm going to get an error because the code doesn't know what the function is. So in that case, what you do is that you say that it's going to be a void function, or in other words, you let the compiler know that there's going to be a void, or it's going to be a function with that name and semicolon. So here you don't open and close with curly brackets because you're not defining the function here. If you define your function after the main function, you simply have to let the compiler know that the function exists. So that's sometimes more work. So I like to define my functions up here. But if the code is too large, then this might become cumbersome. So it's probably a good idea to define it beforehand and just declare it, or have the function defined after the main function. So in this case, we can do back to my function, and here I can do a for loop for int I equal to 0 for I less than size, and I plus plus do $d, comma I, comma array. So in this case, we are missing an I here to print the value of each member of the array. Excellent. So in this case, we are printing the values of each element of the array. So notice that the elements of the array were 0, 1, 2, 3, 4, and the size of the array is 5. So when I input the array and the size of the array, then I can use the size to create my for loop.